Modern science describes our reality through isolated, mathematically incompatible silos. General relativity defines gravity as smooth space-time geometry, while quantum mechanics maps a frantic swarm of subatomic probabilities. These frameworks completely lack a shared structural foundation. This structural friction extends to human systems, where cognitive AI architectures and complex social governance models operate without unified bridges. International policy frameworks lack the mathematical constraints found in the hard sciences, often resulting in uneven enforcement and systemic instability. Without a shared structural grammar, any attempt to unify human knowledge, from subatomic particles to global economies, eventually collapses under its own contradictions. The universal convergence hypothesis proposes that all comprehensive descriptive frameworks eventually converge on a single mathematical structure. This convergence point acts as a structural attractor, composed of exactly 3 orthogonal axes required for any stable system to exist. The first axis is form, the system's identity, structure, and internal definition. The second is position, the system's context and its relation to its environment. The third is action, the system's dynamics and the cost of its interactions. These 3 axes generate a formal equation. Stable existence is the tensor product of form, position, and action. This triadic logic functions as a formal mathematical necessity. The U model derives these axes from the core structural requirements of information stability. Identifying this universal triad provides the necessary link between abstract physical laws and operational reality. We can verify this necessity by testing the limits of the model, specifically by attempting to build a system with only 2 axes. If we attempt to isolate form and position while entirely removing action, the system's dimensionality collapses. The result is a static mapping, a geometry devoid of systemic cost or energetic exchange. Conversely, a system with form and action but no contextual anchor of position has no boundary and violently tears itself apart. Every bipartite framework fails because it leaves one irreducible question unanswered. Which specific thing is it? Where is it contextually located? Or what does it do? When a framework lacks a critical axis, theorists must patch the missing dimension into the math using auxiliary variables to maintain stability. The second proof track examines the information theory behind why systemic completeness requires exactly 3 components. We calculate systemic stability using a non-compensatory geometric mean. In this logic, an infinite supply of form cannot compensate for a 0 in action. If any single variable vanishes, the stable existence of the entire system collapses. We can formalize this balance through the Hadamard optimality theorem, applied to a diagonal Fisher matrix. The information volume of the system is bound by this inequality. Maximum information volume is achieved only when form, position, and action are balanced with equal information content. This balance is a mathematically proven optimal state for information distribution. This minimality confirms that the FPA triad is the non-negotiable floor for generating stable existence. The third proof track is isomorphism, which shows us that this abstract mathematical structure maps directly onto our physical operational reality. Any complete operational framework admits a structure-preserving mapping back to this exact baseline. We see this in the 3 irreducible categories defined by Charles Sanders Peirce. Peirce's firstness, or quality in itself, maps directly onto the concept of form. Secondness, defined as relation to another, maps to position. And thirdness, representing mediation or law, maps to the concept of action. This isomorphism also defines the necessary conditions for triadic AI agents. For an agent to function, it must first endure as something, the requirement for form. It must be somewhere distinguishable in position, and it must do something at some cost, fulfilling the criteria for action. Because these conditions have 0 conceptual overlap, they form a stable template that scales from subatomic structures to artificial superintelligence. The U model describes the structural logic of existence rather than the fundamental physical forces. This relationship is defined by the reality equation. The left side represents the system's internal meaning, the triadic coherence of its form, position, and action. This meaning projects into observable resources. Sigma and tau represent the geometry of space and time. E is the energy flux, and W is the thermodynamic waste or entropy generated by the cost of interaction. In this framework, physics studies the observable mirrors of space and energy, while the U model studies the underlying triadic meaning being reflected. The form, position, action triad is the absolute smallest possible description that distinguishes something from nothing. This structural attractor inevitably reappears whenever fields like quantum physics or global governance attempt to map reality comprehensively. It functions as the underlying geometric requirement for any system to be both distinguishable and interactive. This core triad provides the geometric constraints that all descriptive scientific maps must follow to maintain systemic coherence. Spacetime emerges as the measurable cost structure of these triadic relations. Because stable existence requires an interactive cost, action, the resulting universe manifests as a geometry of relational resources and thermodynamic